The invisible hand behind your digital world. Every time you unlock your phone with your face, receive a movie recommendation, or marvel at a self-driving car navigating a busy street, you're witnessing the quiet yet powerful force of machine learning. It's not magic, it's math, data, and intelligence combined in ways that were once the realm of science fiction. Machine learning isn't just influencing your life, it's invisibly scripting it, predicting your needs, guiding your decisions, and learning more about you every second. And the most astonishing part? It's just getting started. From curious code to life-saving insight. A story from the ERN. A bustling emergency room in Boston. A young doctor glanced nervously at her screen. A patient had just arrived, presenting symptoms that mimicked everything, from the flu to a heart attack. Time was running out, but beside her, a machine learning-powered diagnostic tool silently analyzed thousands of data points, vital signs, medical history, blood results, and flagged the early signs of sepsis, a potentially fatal condition. The doctor trusted it. She administered treatment immediately. Hours later, the patient's life was saved. This isn't a futuristic fantasy, it's reality in hospitals today. What began as experimental algorithms are now trusted companions in life or death scenarios. Machine learning is no longer confined to labs or laptops. It walks among us, learns from us, and occasionally saves us. Why you shouldn't just watch? You should join. Machine learning isn't just for tech giants or PhDs in data science. It's a movement that's reshaping every industry, from agriculture to art. Whether you're a business leader aiming to stay competitive, a student plotting your future, or a curious mind fascinated by innovation, this is your moment. The tools are more accessible than ever, and the need for human-guided ethical intelligence has never been greater. Don't just be a user of machine learning, be a shaper of it. What exactly is machine learning? Machine learning, ML, is a subfield of artificial intelligence, AI, focused on building systems that can learn from data and make decisions without being explicitly programmed. Instead of following static instructions, ML models improve over time as they process more information. Imagine teaching a child to recognize different types of birds. Initially, you show them examples. This is a sparrow, that's a crow. Over time, they begin to recognize birds on their own, even unfamiliar ones, by learning patterns like size, beak shape, and song. Machine learning works in a similar way, only instead of feathers and beaks, it processes numbers, pixels, and patterns. How machine learning works. The life cycle. The process behind machine learning is both art and science, involving several steps. Data collection. Everything starts with data, tons of it. The more diverse and accurate the data, the smarter the model can become. Data preparation. Raw data is messy. Cleaning, formatting, and handling missing values ensure the machine has quality fuel to learn from. Model. Selection. Depending on the task, whether predicting stock prices or grouping similar customers, different algorithms are chosen, such as decision trees, support vector machines, or neural networks. Training the model. Here, the algorithm learns from data by identifying patterns and adjusting internal parameters for better accuracy. Testing and validation. To ensure reliability, the model is tested on new, unseen data. This checks whether it has truly learned or just memorized the training set. Deployment and monitoring. Once accurate, the model is integrated into real-world applications, from chatbots to fraud detection systems, and continuously monitored. To keep learning, the four major types of machine learning. 1. Supervised learning. This involves training the model on labeled data, where the input and output are known. Applications include email spam detection and credit scoring. Unsupervised learning. Here the model explores unlabeled data and uncovers hidden structures, like customer segments in marketing. Semi-supervised learning combines a small amount of labeled data with a large amount of unlabeled data, offering a balance between performance and resource efficiency. Reinforcement learning. This mimics how humans learn through trial and error. Algorithms learn optimal actions through feedback, commonly used in robotics and gaming. Transformative applications. Across industries, machine learning is no longer an exotic experiment. It's embedded in the tools we use daily and the systems that run our world. Healthcare predictive diagnostics. ML can detect cancerous cells in scans with greater accuracy than humans. Personalized medicine. Algorithms help tailor treatment plans based on genetic profiles. Finance fraud detection. Real-time flagging of suspicious transactions. Algorithmic trading. Automating trades based on market signals. E-commerce recommendation. Engines. Predicting what you'll buy next. Dynamic pricing. Adjusting prices based on demand and competition. Agriculture. Crop health monitoring. Drones and ML assess field conditions. Yield prediction. Anticipating harvest volumes using environmental data. Transportation. Autonomous vehicles. Self-driving cars learn from countless hours of driving data. Route optimization. Predicting traffic to optimize delivery paths. Challenges. The double-edged sword of intelligence. While the benefits are immense, machine learning also presents complex challenges. Data bias. If the data is biased, the outcomes will be too. This can reinforce societal inequalities. Privacy. Machine learning often requires vast amounts of personal data, raising ethical concerns. Interpretability. Complex models like deep neural networks can be hard to understand and explain. Security. Adversarial attacks can manipulate models by feeding them misleading data. Addressing these challenges requires not only technical solutions but also ethical frameworks and public oversight. The road ahead. Trends shaping the future. Machine learning landscape is evolving rapidly. Key trends include explainable AI, XAI, making models more transparent to foster trust and understanding. Federated learning, training algorithms without transferring data, enhancing privacy. AutoML, automated machine learning tools that simplify model creation. Quantum ML, combining quantum computing with machine learning to solve complex problems faster. The future holds endless possibilities, from curing rare diseases to automating everyday tasks, and machine learning will be at the center of it all. Final Thoughts: machine learning is not just a buzzword, it's a paradigm shift. It's altering how we work, live, and think. Whether you're a student, entrepreneur, or professional, the time to engage with this technology is now. Start small, learn a programming language, take an online course, or explore open source ML tools. The future is being written in algorithms, and your story can be part of it. Will you watch the revolution unfold or help lead it?